Something unusual has been spotted on the moon, and it's getting attention for a reason. New high-resolution observations linked to NASA's Artemis program revealed areas where the lunar surface appears to have shifted, cracked, or partially collapsed. In some images, it even looks like a section of the moon has broken away. At first glance, this sounds extreme. The moon is usually described as geologically inactive, a stable and unchanging world. But the data tells a different story. Certain regions now show surface features that were not clearly visible in older imagery, suggesting relatively recent changes. The key to understanding this lies in how the moon actually evolves. Even without plate tectonics like Earth, the moon is still slowly changing. One of the main reasons is temperature. The lunar surface experiences extreme swings from about 120 degrees Celsius during the day to 130 degrees Celsius at night. These rapid changes cause the surface material to expand and contract over and over again, gradually weakening rock structures. Over time, this leads to cracking. Another major factor is the moon's internal cooling. As the moon slowly loses heat, its interior contracts. This process creates stress in the crust, forming features known as lobate scarps, which are essentially small cliffs or fault lines. Data from NASA's Lunar Reconnaissance Orbiter has identified thousands of these structures, some stretching for several kilometers. What makes them important is their age. Many of these scarps appear relatively young, which suggests the moon is still tectonically active on a small scale. There is also direct evidence of seismic activity. Instruments left on the surface during the Apollo missions recorded moonquakes with magnitudes up to about 5.0. These are strong enough to shift surface material, especially in areas where the ground is already unstable. Recent analysis shows that some of these lunar faults may have been active within the last 50 million years, which is extremely recent in geological terms. In some regions, boulders up to several meters in size have been observed at the base of cliffs, likely dislodged by seismic activity. Computer models suggest that even a moderate moonquake could trigger cascading rockfalls across unstable slopes, especially near the lunar poles where future missions are planned. This means that what looks like a small surface crack in satellite images could actually be part of a much larger and ongoing structural shift. In several locations, high-resolution images show slopes that appear to have partially collapsed. Loose material has moved downhill, leaving behind fresh-looking surfaces that stand out from older terrain. In some cases, this creates the visual impression that a chunk of the moon has broken off. In reality, these are most likely landslides or regolith movements triggered by moonquakes, temperature stress, or both. Micrometeorites add another layer to the process. The moon has no atmosphere, so even tiny particles strike the surface at high speeds. Over time, these constant impacts disturb the upper layer of dust and rock, making it easier for material to shift when other forces act on it. All of these factors combined make the lunar surface more dynamic than it appears from Earth. For scientists, this is not just an interesting detail. It has practical implications. Missions like Artemis are focused on long-term exploration, including future landings and potential infrastructure on the moon. Understanding which areas are stable and which are prone to change is critical. Regions with active fault lines or loose surface material could present risks for landing spacecraft or building equipment. That is why updated mapping and continuous observation are so important. At the same time, these changes provide valuable scientific insight. They show that the moon is not completely inactive. It is still evolving, slowly reshaping its surface through small but continuous processes. The idea that a massive piece of the moon suddenly broke off is not supported by current evidence. But smaller-scale changes are happening, and they are measurable. And in some cases, they can look dramatic enough to raise new questions. Because when we look at the moon with higher precision than ever before, we are starting to see something unexpected. A world that seemed frozen in time is still changing.
Recently, Chinese scientists discovered something interesting on the moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the moon. The mission was named after the ancient Chinese deity of the moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the moon, it spent several days digging through the surface and rocks, and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the moon. It sounds horrifying, but in reality, the birth of the moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery, but that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual, a rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chang'e, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we've found on the moon and the first one found by China. Now, it has become the 3rd country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? Because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, put out the sun is burning, and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, you guessed it, it's the moon. We think that there's more helium-3 on the moon than on Earth because of the solar winds. The sun has been hammering on the moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us. These crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy.
Sometimes when you look at the moon, you see a face smiling down at you from the moon's surface. Of course, this is an illusion, but many people see it, and that's because its surface is shaped by some sort of lunar seas and highlands. From our point of view, we see these as light and dark patches. These seas are dark parts, and large hardened lava plains formed because of volcanic eruptions that happened a long, long time ago. The light regions are actually the mountains and the highlands. And people all around the globe see these lunar patches as a smiling face or even some other shapes. Our brain tends to play with things of this nature, and that's a phenomenon called pareidolia. It's when you see familiar faces and shapes even though they're not actually there, similar to how you can see a face in a slice of toast or shapes while watching the clouds. And in the northern hemisphere, people see a face in those different lunar seas. The eyes are the sea of serenity and rain. The sea of clouds represents his mouth, while the seas of islands and vapors form his nose. But that's just one way to interpret this picture, and that mostly works in the northern hemisphere. If you live in the southern hemisphere, you see the moon the other way up. When they look at the moon, some see a person that looks like they're carrying a bundle of sticks. Or there's the shape of a woman. She wears her hair up and it has 2 jewels in it, and they see the left side of her face in profile. One of the craters is reminiscent of a shining diamond which, it seems, she's wearing around her neck. In some places, people may see the shape of a rabbit, whereas people from the Pacific Northwest in America even have a story about the toad they see when looking at the moon. The story says there was a wolf that fell in love with a toad, and the toad didn't quite trust the wolf since it wanted to escape and didn't know where. It simply made one huge leap and landed on the moon. Now, do other planets have beautiful rainbows like we do? The ingredients for that are raindrops and sunlight. At the moment, we don't know of a planet with liquid water on its surface, and none have enough water in their atmosphere to make it rain. But droplets of some other liquid could refract light coming from the sun and spread it out into various colors. Titan is one of Saturn's moons, and the atmosphere there is rich in droplets of liquid methane, which probably form rain. The atmosphere on Titan is very hazy. That means that direct sunlight is not that common, but there's still a slight chance we could catch methane rainbows someday. If they really exist, they'd be similar to rainbows on Earth, but they'd be a bit broader because methane refracts light differently than water. There's a similar thing on Venus called glory. Scientists caught pictures of this optical phenomenon of sunlight falling on sulfuric acid droplets, similar to a rainbow. Jupiter is insanely big, around 11 times wider than Earth. Not only that, our planet is twice as small as its Great Red Spot, the raging storm that's been present on the planet for more than a century. Now, we owe Jupiter a lot. Its radiation is 1,000 times stronger than the lethal level for us, and the gravitational force is so powerful that it actually protects our planet from collisions. In some other planetary systems, giant planets like Jupiter can move around and migrate from the place where they were originally formed. They spiral inward and get closer to their stars. When they move around, they can cause a lot of trouble. When they get closer to their stars, they can swallow and destroy some innocent small planets or other celestial bodies that stand in their way. But if these giants remain far away from their stars, they serve as guardians of the planetary system. They protect the planets in the inner orbits and allow them to circle around a central star. Jupiter got the nickname vacuum cleaner of the solar system because it can eat up any comet or asteroid that comes close enough. It can also change their orbits and kick them out so they can't come back for a very, very long time. That way, Jupiter protects the inner planets, although sometimes it accidentally sends asteroids or comets into them, causing collisions like maybe the one that made the dinosaurs extinct 65 million years ago. Now, Saturn's rings are the most famous ones in our solar system. They are far-reaching, colorful, and highly visible. You can even see them using a backyard telescope. But some other ice and gas giants also have them too, like Uranus. It has the second most interesting set of rings in our solar system. There are 13 rings, and they're all made of very dark particles that are different sizes. They're most likely young, way younger than Uranus itself. One theory says high-speed impacts shattered one or more moons, and this may have been the matter these rings are formed of. There were way more particles of debris, but only some survived, and today are forming stable zones around Uranus, known as rings. Now, our planet lost 60% of its atmosphere when there was an asteroid impact that, as one theory says, probably created the Moon. The collision between Earth and a Mars-sized rock happened over 4 billion years ago. The debris from all that, collected in an orbit around our planet, eventually formed the Moon. Now, Venus is home to at least 37 volcanoes that were active recently, which is the first evidence that showed its interior is still geologically active. Previous research discovered that the planet's interior was warm, plus there were ring-like structures. Plumes of extremely hot material deep inside Venus rise through the mantle layer, and that's how these structures form. It's like how plumes form the volcanic areas of the Hawaiian Islands. But scientists think they were just a result of some ancient activities. They believe Venus has cooled enough and drastically slowed down geological activities in its interior by hardening the crust so much that all of the warm materials from deep inside can't get out to the surface. Speaking of volcanic eruptions, Jupiter's moon Io also has them. Our moon is pretty peaceful, but Io has hundreds of volcanoes, and it took the title of the most active moon in our solar system when it comes to volcanoes. If you could go there, you'd see plumes of sulfur that reach up to 190 miles into its atmosphere. Volcanoes there emit 1 ton of particles and gases into space near Jupiter, its parent planet, every second. This could be because Jupiter's strong magnetic field and gravitational force. Io's interior tenses up and relaxes as it orbits Jupiter and gets closer to it and farther away from it, which generates huge amounts of energy, enough for volcanic activity. There are billions of comets in our solar system. Most of them are in the Oort cloud and the Kuiper belt. A comet generally consists of rock and ice, at least until it gets closer to the Sun. Then its exterior turns into a cloud of dust and gas. And that's why comets have their specific tails. Pluto's unique surface is a series of domes, peaks, and troughs on the planet's landscape, which may have been formed because of its many large ice volcanoes. Neither erosion nor some other geological activity has done that much, but its ice volcanoes actually push icy material up to the surface. There are also a couple of craters in this area of the hemisphere called New Horizons. Asteroid impacts probably caused these. Plus, these craters aren't that geologically old. Also, the interior of Pluto probably retained heat, which enabled matter rich in water and ice to deposit onto the surface. And those specific structures I mentioned before could have formed because the water was rising up from the interior of the planet and ended up being rapidly frozen because temperatures on Pluto are extremely low, in addition to atmospheric pressures. Uranus is the second least dense planet in our solar system. The least dense one is Saturn. Now, even though Saturn is 14.5 times as massive as our planet, it's still less dense than water. This means that Saturn would float in a pool if it was more than 37,000 miles wide, so the planet would have enough space to even be in there. Whoa, that's a big pool. Now back to Uranus. Since its density level is so low, you probably experience less than 90% of its gravity, assuming you could even set foot on its cloud tops. Now Mars has pretty crazy dust storms, the biggest ones in our solar system actually. They can blanket the whole planet and last for months. One theory says these huge storms start because dust particles absorb sunlight and warm the atmosphere of the red planet. Warm pockets of air form and they start flowing toward colder areas. This generates winds. These powerful winds lift more and more dust off the ground. This again heats the planet's atmosphere, creates more wind, and kicks up even more dust. Wow, better have a broom handy, maybe even two.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Progyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.